Hi guys, in today's video I would like to show you how you can read the data from BMP280 and send them to the mobile application and display them in a chart. So from this module I'm reading temperature, pressure, and I also calculate an altitude, and I plot them in these three charts. So as you can see, I have these three charts where the first one is temperature, the middle one, green one, is pressure, and the blue one down below is altitude, which is calculated from those two values above. And as you can see, I have two sig bars. So the first one is for update, and when I increase this update period, it reads every 5 seconds. So every time it reads this value, the LED on STM32 board blinks, and this STM32 board works as a server, so it waits until some requests arrives, and when it receives the request, it sends the message back. So this module waits until this Android application sends the get message, and this way this application asks for a data. And also, as you can see, I can decrease this period to lower, for example, for 2 seconds. And I have limited the displayed data to 120 samples. So when you have an update period of 1 second and all of these data are displayed, then you have, in this case, 2 minutes displayed in a chart. But when I, for example, decrease this value, now I have only 20 seconds displayed. As you can see, I've been running this for more than 2 hours. So that's why I have there 8,700 seconds. And I can also clear the chart. So when you don't have a data, as you can see, those data are squeezed into that chart. So you still can see there the 0th second. And when it loads the first 20 samples, then the first samples are removed. And this way, these charts looks like they scroll to the side. So that's it. And I also have this switch. And now I have disabled the sending the get message. So this application doesn't ask for a data. So as you can see, this application is like a client, and this STM32 board works as a server. And I'm using a Bluetooth Low Energy module, JDY-08. So that's basically it. So now when I turned the reading on, as you can see, I still track this chart in a time properly, because basically I read the time from the Android phone, so I get the correct time, I get the proper time from the operating system itself. So that's how I assign those values to the time. So that's basically it. And by the way, I'm really glad that I have 201 subscribers, so thank you for that. And if you are new, don't forget to subscribe. And with this being said, let's get started. Let's start with this STM32 project, which has BMP280 pressure sensor on it, and also JDY-08 Bluetooth Low Energy module. And this Bluetooth Low Energy module uses UART2 as peripheral, and its baud rate is set up to 115,200 bits per second, or bauds. And I've enabled global interrupt for it, and I'm also using this timer to time out the receiving time. So when the receiving time takes too long, I just basically launch the message handler and clear the buffer in case it was received incorrectly. And for the pressure sensor BMP280, I'm using I2C peripheral, where I don't use any of these interrupts, and the speed is set up to 100 kilohertz. And I have two GPIOs over here. One is for the LED, and the second one is for the Bluetooth module to reset it. And the clock is basically set up to maximum, so that's basically it. So let's move to this code section. First I initialize all the peripherals, then I toggle the GPIO level from low value to high value, and wait 1 second, and this allows the Bluetooth Low Energy module to boot up. Afterwards I name the Bluetooth module as BMP280, and then I clear the buffer, start the timer, and then I enable global interrupt for the UART, and this timer is set up to 20 milliseconds. And afterwards, after I enable this interrupt for UART, then I initialize this BMP280 module, and I made this whole code, including the library for the BMP280. So let's have a look at this BMP280 library. I've wrote down these definitions. So this module has only 2 registers for configuration. So it has F4 and F5 register, and I've grouped up these options to these few lines. So you have, for example, oversampling for temperature, oversampling for pressure, and the run mode. And also you have in this register the sleep mode in between the measurements, and also the filter settings and SPI mode. And over here I have these functions which can read and write registers, get calibration values, which are in read-only memory in the BMP280. Here I have this init function, and this is the main function that reads and calculates all the values from BMP280. And this complex calculation is pulled out of the datasheet. So this was included as a pseudocode in the datasheet. So everything is available in here. This datasheet is quite short for a sensor, but it was good for me when I was making this library. So for example, you have a table with settings where you can see that you can increase the resolution from 16 bits up to 20 bits, and the noise goes down. And the same works with the temperature. So higher oversampling, lower the noise, and higher the resolution is. So that's basically it. And also you can set up this infinite impulse response filter. And as you can see, you have also an equation, and this table also shows how many steps it takes to reach over 75% of the new value of infinite impulse response filter. And down here should be the code somewhere. Yeah, so this is basically it, what I was following. But I think, yeah, I was following this part. So here you have all the addresses, all the names of the variables, and I followed this code. So it is basically over here. And up here I have these variables, and it is basically rewritten from the datasheet. And let's get back to the code functionality. So in this my library, I have only basically three functions: f2a, float to array, which converts a standard regular float to array of strings, array of characters, and also into the string. And I have this string compare function, which compares two strings, and when they perfectly match, it returns 1, and if they don't match, it returns 0. And lastly, I have a message handler. So as I mentioned, this is the float to array function. This is the string compare function. It's quite short, and this message handler just compares the received message with the buffer, and if it matches with the get word, it reads the values from the BMP280, puts them into the string. So first goes temperature, then pressure, and then altitude. These values are separated with comma, and I've added there this end of line character. And at the beginning, I turn the LED on. I'm turning the LED on by toggling the GPL level to low, and by toggling it to high value, I turn off the LED, so it basically blinks every time. And then I clear the buffer and reset the variables for the receiving. And when I open this interrupt code, I have this UART2 for receiving. So basically every time I receive a character, I write it down to the buffer and increment the index. So it writes a character by character into the buffer, and then I check and verify if the last character is end of line. And when I receive this end of line character, then I launch this message handler. But over here I have this timer 2, which is launched every 20 milliseconds, and I check if the buffer is empty, and when it is not empty, I count the timer variable up, and when the receiving takes more than 100 milliseconds, then I launch the message handler. So I'm receiving such short messages, and the baud rate is so high, over 100 kilohertz, so it is 115,200 bauds or bits per second. So it is so fast, so it cannot even take 20 milliseconds nor 100 milliseconds to receive. So when it takes too long, I just launch this message handler. So that's basically it for this STM32 project. And by the way, this project is available on my GitHub, so you can go on and download it. And now let's move on to the Android Studio application. Let's continue with this Android Studio project. As you can see, I have 3 charts in here, but these aren't available by default in Android Studio. I had to import an external library via Gradle. So I went to GitHub and found this MPAndroidChart from Phil J, and he've made an amazing library. So as you can see, he made a line chart, a different type of line charts, and also bar charts, and also these pie charts. As you can see, they look amazing, and you can use them as you want. And all you need to do, you need to use Gradle, Build Tool, or Maven, and you just need to add these lines to your code, and they will be imported. So I selected this Android view over here, and then I opened this Build Gradle module application. So it's this one, and I have put there into repositories this Maven URL, which is over here, and also this dependency. So that one is over here, and this Gradle automatically imported all the necessary stuff, and suddenly I had these available, so I was able to put them into my layout. So let's move to this Java code. So basically over here I control all the activity. So I use ArrayList to collect those data points, those data sets, and they are made of entries. So I have separate array list for temperature, pressure, altitude, and to periodically update those charts and send that request to my Bluetooth server. I use this handler, and by default I have selected this update period to 1000 milliseconds. So it's 1 second period, and I have a few objects, as you can see over here, and I have this data set which is set to 20. It's also for the seekbar, for this data set seekbar. So that's the limit which I use to trim the size of these array lists. So let's go to structure. So this message handler is launched every time I receive a message, which contains end of line character, that \n. And over here I just split that message to separate substrings, and basically those values are separated by comma. So when I split it, on 0th position I have temperature, on 1st position there's a pressure, and on 3rd and on position number 2 there's an altitude. And basically here when something goes wrong, I set those values to basically impossible values, and then I verify if this message handling went well, and if it was okay, then I basically put those values into the chart. And when the data set is too big, I basically trim it down, and then I update the chart. So this is how I initialize the charts. So basically I just find view by ID, so I just link this Java object with this XML object, and I repeat it basically 3 times. So in onCreate I have, for example, set the flag for the keeping the screen on. By the way, I had to make a cut. So basically with this line I keep the screen on, and with this line I set the screen orientation to portrait, so the screen orientation doesn't rotate. So you should apply this to every activity. You need to keep this screen at portrait mode, and I also had to suppress lint for the locked orientation activity. So that's basically it. And also during the scan activity I've created this autoconnect function, which is launched from here, and when I basically scan new devices, I try to compare the name of the device with this BMP280. So that's the name of my Bluetooth module, and when it's equal, I auto-connect to that device. So that's it. So let's continue with the video. And over here, I just set up the layout. Basically, I just connect those XML objects with Java objects, and set up on action or on SIGBAR change listeners. So here is the logic of the program basically set up, and here you can see the handler, which is launched periodically, and that's basically it. So every time I just send this get command, and every time I receive message, I just launch this message handler. So this message handler is launched from this place. So it is a broadcast listener, and every time there are new data available, I just stitch together different packets because the message may be split into sub messages which had to be stitched together, and when the complete message contains end of line character, then I know that the receiving is complete, and I can run this message handler. But before that, at this line I remove that end of line character. So when I do the message handling, it doesn't contain that end of line character. So that's basically it, and I can run debug and show you how the message looks like. So let's break it over here, and let's run a debug. It's currently building, and soon it's going to be installed. So it's being installed. This is the previous version being running, but now it's launching a new activity. Yeah, so now it's scanning, and now it's connected, and now I need to turn this switch on, and now I have received the first message. So when I expand this class, I have to look for receive buffer. So as you can see, this is the message. So here are all the characters, one by one, and here is the complete string. So that's basically what this buffer contains. And here I should see all the variables which are over here. So the temperature, pressure, and the altitude. And by the way, this module was laying in my drawer for several years, and I think it's quite damaged, so these values aren't correct, but I know from my experience with these modules, with these BMP280s, that they are quite sensitive and quite accurate, but this one is possibly damaged or something. But as you can see, this way you can explore this application and find out how it works and try to reverse engineer my code. So consider this to be as a template, and you can learn from it a lot. So that's basically it. And I recommend you also to read something about Gradle and Maven automation tools, automation systems, which can import different types of libraries, because when you think about it, you don't have to manually download a jar and manually import it into your code, which is wasteful, and it takes a lot of time. But this way you can look for a library you want, and it is portable. So when you move your project from one machine to another, it as long as it contains this Gradle or Maven, the project itself can import every library it needs. So it's quite interesting topic to be learned. So that's all for today's tutorial. So thanks for watching. Bye.